Okay, so we're going to now use the derivative to, listen, the derivative, that's half the calculus that you just learned, except it's, you can use it a lot of different ways. Okay. Always remember that the derivative represents what? The slope of a curve. Slope at a point on a curve, okay? Yeah. That's what the derivative represents. So we're going to talk today about equations of tangent lines. Equation of a tangent line. So to write an equation for a line, you always just need two things to do that. You need two things. So whenever you see a tangent line question, equation of a tangent line, you just tell yourself, I need two things. What are they? A point and a slope. A point and a slope. And then we talked earlier this year about writing things in point-slope form. And this is why, because this is much easier to do it that way, okay? So you need two things, a point and a slope. The point's either given to you, or just the x is given to you. But if just the x is given to you, it's easy to get the y. You just plug the x into the equation and you get the y. Alright? The slope comes from what we've just been doing, which is a derivative. Alright? So what we're really talking about here is, say we have this curve and we want to know the slope, we want to know the equation of the tangent line at x equals, say, 5. Okay, so the tangent line looks something like this there. And we want the equation of that line. Okay? So we can use that point and we can do the derivative to get the slope and just plug those into the point slope form. Okay? So let's say we have y equals 2x cubed plus x minus 4, and write the equation of the tangent line at x equals 1. Okay. So you need two things. You need a point and a slope. What you have is an x, so you're going to need a y. But that's easy to get because you just plug x into the original to get your y. So in this case, y equals 2 times 1 cubed plus 1 minus 4, and that is equal to what? -1. So y is -1. So then I always like to write the point down here. So 1, -1 is the point. Now to get the slope, that's doing what you guys are just doing. So you take this equation here, and we're going to go y prime, right? Just like f prime of x, y prime, that's the derivative, equals what? 6x squared, yeah, plus 1. Yeah, 6x squared plus 1. Okay. Now the x is still the same. The x is still this 1. All right. So now you plug that into the derivative to get your slope. Yeah.
Wait, how did you get this?
Do the derivative of this.
Oh.
So 6 and goes down. So okay. Now we're taking this 1 and plugging it into that also. So that is going to be 7. Right. So the slope is 7. The point is 1, -1. And now you just write your point slope form. Remember how to write the point slope form? Y minus y1, that happens to be negative here, so it's actually going to be y plus 1 equals m times x minus x. Okay, so that's your equation. Now you don't have to solve that for y. The only time you would ever have to solve that for y is if it was a multiple choice question and that's the way the answers, that was the form the answers are in. Otherwise you're done. This is the equation of the line right here. Point slope form. Okay? That's done. Y minus y1 equals m times x minus x. So that's the point slope form of the line. So make sure you, I should have wrote that probably first. But you're always going to be using that. Put these in this point slope form. Okay. All right. So just real quick again, you plug x into the original to get y. You plug x into the derivative to get the slope, and then you just write your point slope form. And
Why is 7
So we did the derivative right here of y. We get y prime is 6x squared plus 1, and we're plugging 1 in for x into that also.
So the derivative
Yeah, derivative is always for the slope. Okay. So why don't you try a couple of those? Let's see, not that. That's what I just did. Yeah, okay, there's a few. So, do these right now, we'll go over these, and I'll give you a couple more. Okay?